Okay, so we've got an integral here, x divided by cosine squared of x dx. And this is an indefinite integral, so we've got no limits of integration here. So how are we going to go about doing this? Well, u sub's not going to work, trig sub's not going to work with this cosine squared x because of the x on the top. So let's just break this function apart and let's see what we've got. So what we can say this function is x times 1 over cosine squared of x dx, all with respect to x. So from looking at this is an integration by parts question. So let's just write down the formula for integration by parts. So u dv, that's the integral, so that will be this, equals u v minus another integral of v times du. So what that means is we have to assign a u and a dv to one of these and then find the derivatives and integrals of each part of these. So looking at this, best way to go for this would be the x to be the u. So we'll let u equal the x. And the dv, we'll let that equal 1 over cosine squared of x. Okay, so now we need du. So derivative of x, that's just 1. Just on second looking at this dv here, 1 over cosine squared x. Now we know what that also means. That dv here is also secant squared of x. And when we know secant squared of x, we know that this has a very famous integral, namely tangent x. So what we can say is that v equals, let's just write that properly, tangent x. So we've got a v, dv, du and a u. So these are our four main components to solve this integral. So now let's write this out. So the integral of u dv, so that's x secant squared of x dx. So that's the same as this. We just change that for secant squared of x. That equals u times v, so x tangent x, minus another integral v times du. So v is tangent x and du is just 1, so we don't need to write anything in there. So we'll write that with respect to x. Okay, well, x tangent x, that's part of the answer. Then we need to subtract the integral of tangent x. Well, tangent x has a very famous integral. So integral of tangent x equals, now that, let's just write that here, just gives a little bit of room to make sure we fit it all in. So that equals minus natural log of cosine of x. And because we're dealing with natural log, just to be careful here to increase the domain of this possible function here, we need to include absolute value. Okay, so now that we know that, we can just plug that in here, see where we get to. So x tangent x, part of the answer. And then if we subtract this, we've got negative, negative, so we end up with a positive. So plus natural log cosine of x, and then plus c. That is our answer.